Dagomar Degroot is an associate professor of environmental history at Georgetown University. His first book, called The Frigid Golden Age, was published by Cambridge University Press. And in 2018, his next book is called Ripples in the Cosmic Ocean. I think it is not yet out, if that's correct. And you heard yesterday that climate history is a truly interdisciplinary pursuit. And Dagomar Degroot publishes equally in historical and scientific journals, which I think is an indication of that Sam was talking about. He is the co-director of the Climate History Network with Sam White, which is an international group of scholars who are working across disciplines to reconstruct past climate and also investigate how climate intersects with history. So I put that resource on the webpage for this if you want to look at it. He also co-directs the website historicalclimatology.com, which is also on the site, where I would recommend looking for articles on this topic. If you want to keep learning, I'd recommend looking through those articles and listening to his podcast maybe first. He also writes for Popular Audience in like the Washington Post and Aeon magazine. And so with that, I am going to introduce Dagomar Degroot. Thank you for joining us.
Okay, so thank you so much for inviting me to be part of this. Thank you for putting it on. This is super exciting for me, actually. You know, a lot of my work has been focused on university students, on the general public, on my colleagues, but really very little on high school students. And I think that's actually the perfect demographic, the perfect students to encounter what we call the history of climate and society, sometimes also called climate history, for the first time. So yeah, it's a real thrill to join all of you this afternoon. Wish I could do it in person, maybe someday. So what I want to do here is introduce you to the field even a little bit more than Sam has already done. I will introduce you to some new approaches in the field. It's going to get, I guess, a little technical. I'm going to kind of break down how we approach causation. That's really the thorny question, kind of working its way through this field in all discussions about climate impacts. How do we determine when climate change has actually caused a social response, right? It's tricky to do. And as you'll see, there's a couple different ways of doing that in this field. There's been a long-standing focus on just a particular kind of response in the field. And I think there's been some pretty serious challenges and problems in the field that have not really been resolved yet. So I'm gonna cover all of that. And then if there's time, I'll show you how a project in this field is actually put together. So how we actually think of a research project and then carry it out, if there's time. If not, we can skip right to questions. I'm pretty sure there are a number of questions after Sam's talk. Yesterday, I had a chance to see that talk, and I know he got into things like paleoclimatic climate proxies and reconstructions and all of this kind of stuff. So if you have questions about that, I'm happy to answer those questions as well. Okay, so first thing I want to do, what I want to highlight is that this field is pretty big now. And this is just a smattering of books that have been published in the field in the last 5 to 10 years. Most of them focus on the Little Ice Age. The Little Ice Age is really the focus of much of the field because it's relatively recent and relatively well documented. And remember those reconstructions, those graphs and maps that show how climate has changed, they're pretty good for the Little Ice Age, but they become a lot more speculative as you go further back in time. What we say is the resolution of those reconstructions goes down, meaning the precision goes down, and that makes them harder to connect to human affairs. So the Little Ice Age really has been a big focus in this field. Now, a lot of these books are written by historians, but at climatehistory.net, the Climate History Network, we actually have a bibliography. You see it on the left here, that lists more than 4,300 publications in the field. So that's an indication of how big it is. And those publications are in a whole bunch of different disciplines: archaeology, economics, geography, genetics, the list goes on, but all of them try to figure out how climate change has influenced human history, for the most part, prior to the onset of anthropogenic global warming, which is, of course, what most of us, until recently, think about when we think about climate change, right? So this is a highly interdisciplinary field. It's a diverse field. And if I can go back actually to that list of books, you can see, even though a lot of these books are on the Little Ice Age, many of them approach the Little Ice Age in different ways. So you can see the book at the top there, Tropical Freedom, Climate, Settler Colonialism, and Black Exclusion in the Age of Emancipation. That covers very different topics, obviously, than Sam White's book, Climate of Rebellion in the Early Modern Ottoman Empire, or my book, The Frigid Golden Age. Tree Story is kind of about the science of reconstructing climate change and how we know about its impact. So all these books are very diverse. And what I want to emphasize is that it kind of doesn't matter what course you teach in high school, right? There's a lot that you can bring in here from this diverse scholarship. Diverse, yes, but there are also two common schools for establishing causation in this scholarship. And one school is what we might call cause of effect. And these are actually Sam's terms. Sam's terms and terms developed by someone called Chin Pei in Hong Kong. Cause of effect. This means of establishing causation uses qualitative methods that we in history use very often. So inferences from historical evidence, comparisons with similar cases where climate might have changed or not, counterfactual reasoning, a lot of sort of counterfactual reasoning, obviously, in the historical discipline. And what we're trying to establish using these qualitative methods is that climate change was both a necessary and a sufficient condition for social changes. So for social changes in particular case studies. So it had to be there, and it actually directly led them to the social change as well. So this is really focused on qualitative, traditional historical reasoning in particular case studies. And that's a good chunk of the field. But an actually a bigger piece of the field, and certainly more influential, is statistical in nature. So the first way to do this is to take those climate reconstructions that Sam introduced you to yesterday, and let's say they're for a particular place. Imperial China is often used in this kind of work, and it has a particular resolution. So let's say it shows you how temperatures are changing annually, so year by year. And let's say it goes back 2,000 years. What you then do is you find some kind of social change that you can quantify according to the same scale in time and space. So let's say the annual frequency of war in the same place, let's say central China. And you line up those two graphs, which is what you end up getting, and thereby look for correlations. So statistically significant correlations in particular to establish the control of the climate variable over the historical variable. So here you're trying to figure out climate change as a cause. Is it a cause of historical changes on very broad, big scales in time and space? But that's not the same thing as determining that it's necessary or sufficient in all instances, in all case studies. So as a result, there's these two schools that are trying to establish causation in very different ways, and often they're kind of talking past each other, right? So they're kind of often kind of attacking each other, not really understanding what they're trying to do. So the field has these two schools, but they're kind of in conflict a lot of the time, which is kind of unfortunate because they have actually used some of the same models or developed some of the same models. This is a model from the statistical school, the statistical side of things. And here it looks a lot simpler from the qualitative side of things. And what both of these models and many others are trying to show is that the most direct impact of climate change on society has been through changes in growing seasons. So growing seasons for common crops might be shortened or might be interrupted. And when that happens, the availability of food goes down in many populations. When that occurs, food prices go up. And if it happens for long enough, starvation, famine will follow. When that happens, migration will often follow, and malnourished bodies will be more vulnerable to epidemics. Sedition comes next, and then ultimately conflict within or between societies. So it's kind of like a vision of our worst case for the future, right? We see that in a lot of the scholarship, we see that time and time again in the past. So these models are very frequently used. And they are, as a result, I think, there's been a overwhelming focus on disaster in the scholarship. So this is a graph that shows just scholarship over 20 years, written by historians on the Little Ice Age in Europe. And that was just to kind of, this is from a recent article, just to constrain how much scholarship we had to go through. You know, it's over 4,000 that we listed at climatehistory.net. And what this shows, first of all, is that there's more and more of these publications that are coming out, but also that overwhelmingly they focus on what we call catastrophe. Right? Again, that kind of focus on growing seasons, the impact on reduced availability of food on society. Yeah, if you're going to focus on that first and foremost, you're going to see a lot of disasters. Another thing that these two different schools have in common is that they tend to focus on at least until recently, on similar times and places. So, for example, ancient Egypt has been a real focus of a lot of this analysis, the drying of the Sahara, and the early phases of our current geological epoch, the Holocene, which led populations towards the Nile River Delta, and then the impacts of flood failures in the Nile River on dynastic transitions and revolts in ancient Egypt. That has been a focus of quite a bit of scholarship now. The disappearance of Viking settlements in Western Greenland has been the focus of many dozens of publications. It coincided with the onset of the Little Ice Age. So there's this idea that cooling led to the extinction of settlements that were established actually in a modestly warmer period, known as the medieval climate anomaly. Then also the apparent abandonment of classical Maya settlements maybe generated more scholarship than any topic in this field. Several centuries earlier, of course, before the extinction, disappearance of the Vikings. And that was related to movement of something called the intertropical convergence zone, where the trade winds converge and there's a lot of precipitation. And that movement of that zone created droughts that apparently might have led to the abandonment of Maya cities. And then Angkor Wat, modern day Cambodia, a very similar relationship has been sketched out here. The movement of that zone, increasing drought, and the abandonment of a city that relied a great deal on canals and water infrastructure. So these are the kinds of case studies that come up again and again. And there's probably about 10 others from ancient to Syria, all the way through the 19th century. It's kind of constant case studies of population societies that were plunged into crisis or collapsed in the face of climate anomalies and changes. There's also been scholarship that tries to bring everything together, combine a whole bunch of these kinds of case studies. Jeffrey Parker wrote a book called Global Crisis. It might be the most influential book on the Little Ice Age at this point. It was published in 2013. And in it, he argued that the coldest phase of the Little Ice Age was responsible for what he calls fatal synergies around the world. And fatal synergies are these connections between reduced, shortened growing seasons or interrupted growing seasons, lower food availability, migration, epidemics, and conflict. And he argues, in fact, that there were so many of these revolts and revolutions in the early 17th century that can be connected to climate changes, that a third of the world's population died. And he's even found statistics, you can see at the bottom right here, the height of French men conscripted into the army. You can see it plunges during the late 17th century. He claims as a result partially of climatic cooling. So there's this huge focus on disaster and catastrophe in case studies, sometimes case studies strung together in narratives like this one. And, you know, a lot of it is true. a lot of it is very legitimate and I think quite compelling to readers, to students. But I became skeptical about some of it while working on this book, which I actually started during my PhD. And it's a book on the Dutch Republic, the precursor state to the present day Netherlands, which I found significant because the Dutch Republic was really a bit of an anomaly in early modern Europe, maybe even the early modern world. It was highly urbanized. It was relatively capitalistic, depended on continent and even world-straddling networks of trade. And it was, in short, a society that had more modern characteristics, what we would call modern characteristics, than most populations and societies at the time. So it was kind of, to me at least, I came to it in part because I thought it could offer an interesting sort of analog with where we are now, even bearing in mind that, of course, in many important ways, as you can see from this picture, right, it was quite different from what we are now. And it had always been strung together when it was mentioned at all, which is not often. It was kind of lumped in with other examples of disaster because, well, scholars have focused on a few political crises in the early 17th century history of the Republic. But I found when I started to focus more on economic performance, military successes, and cultural developments, that the picture is actually much more complicated. It's not as straightforward the story of resilience and triumph. It's much more complicated than that. Often people who died in large numbers were people who were vulnerable on the margins of this society and were therefore located in low-lying areas where they were swept away in storm floods, for example. But in general, there's a lot of resilience and adaptation here too that have been completely ignored. So it's a very complicated, multifaceted picture that I started to uncover. And I started to think more carefully about climate reconstructions, at least after my first few years doing this, when I largely relied on reconstructions that were decades out of date. And so the kind of graphs that you very often see in the history of climate and society, like this one, where we have kind of no idea what the source is for this graph, and there's gaps here that are not explained in the caption of the book. I won't mention the book, but this is an example of a tricky graph, and this one's significantly worse. This has been maybe the most influential, a graph from maybe the most influential book on the Little Ice Age. And here we see trends in climate at the top compared to apparent disasters and major events, but we have no indication of the y-axis. Everything's been smoothed according to a certain filter for smoothing out a graph, but we don't know what the filter actually is, and we don't know what the source is for the graph. And these problematic reconstructions have led to phrases like this one from another recent, very popular book. The Little Ice Age was a global phenomenon that led to a reduction of average temperatures by about 2 degrees Celsius. Now, this is really problematic. I just want to emphasize that, how problematic this is, because we might not have more warming than 2 degrees Celsius this century. If we play our cards right, if we do the right thing, if we lower emissions, the ideal, the hope is that we limit warming to 2 degrees Celsius, right? And a student or anybody who reads a sentence like this one will think, well, the Little Ice Age, we had cooling of about the same magnitude. You know, why do I care about warming in the future? But this is actually wrong. This is off by at least a factor of 4, maybe even the whole order of magnitude, because the climate reconstructions that it's drawing on are probably from books that are, well, like this one, right? Not using reconstructions that would make any sense to a climatologist of the past, a paleoclimatologist. So I think Sam showed a graph that looked a bit like this one at the center here. This is from an article that we published recently in Nature. And this is using 6 different tree ring chronologies. So reconstructions using tree rings, which I think Sam introduced in his talk as well. And you can see, and again, in that center graph, those are all subtly different. And they've got error margins here as well, right? That's a sign of graphs that are statistically rigorous. But at the top, you can see 2 graphs that look rather different. And these are both compiled using assemblages of paleoclimatic proxies, so many different sources, basically, that are interpreted using different statistical methods. And it might seem that both of them show something rather similar, that the Earth's climate was cooling until very recent and dramatic warming. Well, that's true. But they also show very different magnitudes for the Little Ice Age. And if you're trying to connect the Little Ice Age to history, those magnitudes do matter. Which is all to say that if you're doing this kind of work, you really do have to focus on uncertainty and probability. You can't be too confident in what you're writing. And the field is always kind of fluctuating and shimmering, right? So that's all to say that this field, when we're writing about even the present, and how climate change is affecting us now, that's really hard. And we're not always sure. And we have to guard against assumptions. Well, that's especially true when you're looking at centuries or even millennia into the past. So these kinds of early thoughts, when I was working on the Frigid Golden Age, led me to develop these kinds of figures and to publish a recent article in Nature, where I highlight some common problems in the field, and I suggest a way out that I think has broad ramifications. So here on the left, you can see a number of common problems. I think to some extent, this might be interesting actually for high school teachers, to get them to think about the complexity of making these connections, or high school students, I should say, the complexity of making these connections between climate change and social change, right? So in this field, climate data has often been used inappropriately or selectively. We've used terms like climate change or variability or anomaly or shock kind of interchangeably, although they mean different things. We focused, I think, way too much on really big scales in time and space, not local scales and smaller scales in time where human events and responses actually happen, or human ideas are actually born. Often people have taken historical primary sources, right, at face value. So things that are written at the past, they just assume that they are written in the past. They just assume that those sources actually reveal how weather actually changed. That's not always the case. People have different motivations, right, obviously, for writing things. Statistical scholars have fallen victim to so-called McNamara fallacy, which is when you ignore what you can't easily quantify and just pretend like it doesn't matter. Well, sometimes it really does. There's been a selection bias towards crisis and collapse, because scholars usually turn to climate change and usually start thinking about climate change only to explain a crisis that they've identified in the past. Or they consider overwhelmingly, right, agriculture as kind of a first order response of societies to climate change rather than other things. They've made simplistic dichotomies between resilience and vulnerability, and in fact characterize whole societies as either resilient on the one hand or vulnerable, where resilience is often defined as the capability of a society to endure climate changes while retaining its essential features and identity. Societies are not homogeneous things, they're really complicated. And characterizing them as homogeneous tends to lead to scholars ignoring, for example, marginalized peoples within societies who might be more vulnerable, and those more privileged populations that might exploit those marginalized populations in order to become resilient in the first place, right? So that's been a major problem. Correlation, especially in statistical scholarship, but not exclusively, has been too easily associated with causation. This is a common kind of problem when we think about establishing causation in many other areas as well. There's been totally insufficient attention to uncertainty in the field. And most importantly, I think, there's been what we call multidisciplinarity without there being sufficient inter or transdisciplinarity, which just means that often you get people working in one discipline, and then they're trying to draw on other disciplines without really being expert in those disciplines. And what we really want for the field is to get people in different disciplines working together in teams. It's so important. Like, you can't just write about this stuff if you're a historian. Ideally, you want to bring in a paleoclimatologist and maybe a archaeologist, depending on your topic, and the list goes on. People from all kinds of different fields have something to contribute. So as a way out, we create this kind of flowchart. We call it a research framework for thinking through the kinds of questions you have to ask in order to connect climate change to society in the past, but also, I think, for the present and the projected future. So in our opinion, this framework could be useful much more broadly than only in this field. And I think that might actually be quite useful for high school students as well, just working through these questions and thinking through, for example, let's take a very common case study that's often brought up, like the Syrian civil war. Was the Syrian civil war a consequence of a climate-induced drought? What kinds of questions do we need to ask in order to make that connection? This framework could be useful for that too. So using the framework in this study, we identify a bunch of case studies of resilience and adaptation, which we fold into resilience all around the world. And we find 5 pathways, although that's not an exclusive list at all, but 5 pathways for us of how populations could be resilient in the face of these pressures, in the face of climate anomalies and changes. And so you can see here, we really emphasize exploiting, some populations exploited new opportunities as local and regional environments changed. They might have used or developed energy systems that were resilient to shifts in temperature or precipitation. They might have diverse trade networks. They might have flexible political and institutional resources that could adapt. And they might migrate and be transformed, allow themselves to transform in the face of climate changes. It's not an exclusive list by any stretch of the imagination, but it's intended to jumpstart scholarship of this kind. Now, I think I have a little bit of time left, so I want to show you how I developed a research project that was actually folded into this paper and to some extent into the Frigid Golden Age that focused on exploiting new opportunities. So this is a case study from a series of wars, mostly fought at sea, between the Dutch Republic and England in the 17th century. And for me, the first step, so this is, I think, pretty common, well, at least we want to be common in the field, is to identify a change in regional climate. It's one way of doing this. And so you can use tree rings, that proxy that Sam introduced, right, to create graphs like this one. And for me to identify a cold period early in the 17th century and late in the 17th century with modest warming in between. And that temperature changes were relevant to my work, but if you're thinking about war at sea, it's not going to be the most important thing. What might be more important is changes in what we call atmospheric circulation. So how the atmosphere sort of flows across the earth, generating wind. And to that end, I identified state changes in something called the North Atlantic Oscillation. And this looks really involved, but it's actually much more simple than it looks. It's actually pretty simple. There's just a low pressure, low atmospheric pressure zone around Iceland and a high pressure zone around the Azores. And when that low pressure zone isn't that low and the high pressure zone isn't that high, so the difference between these zones isn't that great, we say that the North Atlantic Oscillation is in a negative setting. And when that happens, winds from the west or westerly winds tend to meander into Southern Europe. They kind of flow less with less velocity into Europe, and they meander south. And as a result, there's fewer westerly winds in Northern Europe and more easterly winds. Now, when the NAO is in a positive setting, that low pressure zone is really low and the high pressure zone is really high. So there's a big difference between these zones. And that sort of funnels westerly winds into Northern Europe. So you get more winds from the west now into Northern Europe during a positive NAO. So the NAO is reconstructed partially by looking at precipitation patterns, which means partially through tree rings. And this is a very simple reconstruction of the NAO in the 17th century. And you can see early in the 17th century when it was cold, the NAO is below 0, so it was negative. Late in the 17th century, the same thing, NAO is negative. Midway through the 17th century when it was a bit warmer, the NAO is in a positive setting. Okay, so that was a change that I identified. The NAO is going through these changes, and maybe that alters the amount of westerly versus easterly winds in Northern Europe. Maybe midway through the 17th century, there's more winds from the west in Europe than there were later. So my second step was to develop a hypothesis about a human consequence of these changes. So there's that graph again. Well, those 3 wars, there were 3 wars fought between England and the Dutch Republic, the 3 Anglo-Dutch wars of the 17th century. And here they are with these explosions here. I've identified them. The first war, first Anglo-Dutch war, was fought then, you can see, during a positive NAO. Whereas the second was fought during a very negative NAO. And the third was fought during a modestly negative NAO. So we would expect winds blow from the west a lot of the time during the first war, and from the east much more frequently during the Second and Third Wars. And that mattered. I decided, well, this was going to matter because you have to think this is the age of sail. So wind provides the kind of power source that these ships, these warships need, and it constrains their ability to move in certain directions. So I started thinking, okay, if the NAO is behaving in this way, then maybe wind patterns change in a way that alter how these wars can be fought. So my third step then was to identify the sources that I could use to establish that connection and verify that regional trends actually were affecting local weather. This is one thing to show that the NAO changed using these tree rings, but it's another thing for that actually to be the case at the local level, for that actually to alter winds at the local level. So the sources I used were predominantly ship logbooks. These are almost like diaries written aboard ships. Here you see one example, this one in Dutch. You can see still there's kind of water damage around these ship logbooks that are hundreds of years old. And here you can see a really good example, very legible in English. And you can see it's actually pretty systematic, right? There's entries for every day. And those entries also describe wind direction and velocity. It's important for mariners to record that because that helped them calculate their longitude. So they're always reporting wind direction and velocity. So that was going to be useful for me to create graphs like this one, where I confirmed, yes, in fact, during the First War, westerly winds were a lot more common than they were in the Second and Third Anglo-Dutch Wars. Indeed, that change that we would expect with the shift in the NAO is precisely what happened at the local level. And then I actually used a dictionary that just came out of nautical terms used by mariners in the 17th and 18th centuries. And there are hundreds and hundreds of them used by Dutch mariners. And this dictionary allowed me to translate those terms into modern Beaufort readings. So it's just to say that there's like 12 different states of the sea whereby you can determine the rough velocity of the wind. And I was able to translate these logbooks into that scale. Now at around Beaufort 8, you can see that that's pretty intense wind. The wind's blowing very, very high there. And if you're on a sailing ship, you don't really want to be out at sea in Beaufort 8. But in this confusing graph, I showed that during the Third Anglo-Dutch War, the winds almost always, I shouldn't say almost always, very often blew at or above Beaufort 8. It's really anomalous and strange to see that. And this was significant because these ships had guns arranged in tiers. And the English ships were actually bigger than the Dutch ships, and they had more gun tiers. But when the sea was kind of whipped into a frenzy by these high winds, it could actually flood the lower gun tiers, and they would have to therefore be closed. And so that means that when the winds were blowing hard, the English ships couldn't use all their guns, and they were in fact outgunned in these high winds. Okay, so my fourth step was to invent a methodology to test a hypothesis, which is that climate change influenced the course of the Anglo-Dutch Wars. And my very basic method was to connect regional climatic trends like those shifts in the NAO to local weather events, and then to local human responses. And finally, from that local small scale, right, going back up to thinking about regional historical trends, like the outcomes of wars and the fates of economies and countries and politics and all that. So basically going from the big scale in the global environment down to the very small scale, connecting it to human responses, and then going back up to the big sort of social scale. That was the method. And to follow that method, I created all these databases where I just plugged in everything I knew about weather and the characteristics of battles. And that kind of allowed me gradually to come up with a picture of how these local responses were evolving and the kinds of weather that they were responding to. Okay, then my fifth step was to craft a historical narrative, right, following that cause of effect qualitative methodology that I mentioned to you earlier. To do that, I had to learn about something called the weather gauge, which is something that was really prized in the 17th century in nautical warfare. It meant being between the origin of the wind and your enemy. And it's best to kind of visualize in this painting from the First Anglo-Dutch War. If the wind here is blowing from left to right, this English flagship is in the lee position, which is where you don't want to be. And this Dutch ship is in the weather position. It has the weather gauge. It's in between the source of the wind and the enemy. And that gave it and its sailors what people at the time called the tactical initiative in battle, meaning you could decide when and how, or I should say more easily decide when and how to attack and retreat. So that's what you wanted. And thinking a little bit about the geography of the Dutch Republic or the Netherlands and England, the English fleets almost always sailed into battle from the west, and the Dutch fleets almost always sailed into battle from the east. So if winds are blowing from the west and a positive NAO, that means the English fleets usually have the weather gauge. And if the winds are blowing from the east during a negative NAO, that means the Dutch fleets usually have that advantage. And this advantage was compounded by the ways in which battles were fought at the time. Both the Dutch and the English pioneered so-called line of battle tactics, where they would sail by each other in single file, bombarding each other at range, and then turn around and do it again until one enemy line broke up, and then the battle would be over. And these tactics were greatly facilitated by having the weather gauge. It could allow you to determine how far away you could stay from your enemy, when you broke off to retreat, etc. So the weather gauge was really important, especially for this way of fighting. So here's a map of the First Anglo-Dutch War, and here every battle is a circle, and the victor of every battle is denoted with the flag in the circle. And the wind direction and velocity you can see here with these arrows. So the thicker the arrow, the higher the velocity of the wind. And if the wind was blowing from a certain direction, well, the arrow will point away from that direction. So you can see here in this map that winds overwhelmingly, in fact, exclusively, blew from the west in the First Anglo-Dutch War, in every battle in this war. That often winds didn't blow very hard during these battles, and that the English defeated the Dutch in most of these battles. And in fact, they went on to win the war. And it was only because of some political situations within the Dutch Republic that they didn't impose a very brutal peace on the Dutch Republic. Now here you can see a map of the Second and Third Anglo-Dutch Wars. Now you can see the winds overwhelmingly blow from the east. The Dutch win most of these battles, partly as a result. And often the winds are also blowing at a higher velocity. There's also other reasons why the Dutch won a lot of these battles: technological changes, for example, social changes, cultural changes. But what I was trying to determine is that these changes in the NAO were one factor, and changes in climate were one factor behind the shifting fortunes of the Dutch Republic. And they were able to exploit these new opportunities. And so the Dutch end up winning these wars. And in fact, these relationships extend beyond the sea as well. In the Second Anglo-Dutch War, a fire breaks out right here in London, and an easterly wind pushes that fire all the way into the city. And this is the Great Fire of London of 1666, when much of London was incinerated. And partly because of the fire, the English were unable to field their fleet in the following year, and the Dutch were able to burn it in the River Medway, or burn much of it in the River Medway, by taking advantage of an easterly wind that pushed them into the river. In the Third Anglo-Dutch War, the English actually ally with the French under Louis XIV, the Sun King, and with 2 German cities to declare war on the Dutch. And so there's not only a naval component of this war, but also a major invasion from the south. And the combined English and French fleets, the goal was to invade the Dutch Republic by the sea from the west. But it was so stormy that none of that was possible. In fact, the Dutch were able to dismantle much of their fleet to use its guns to resist the invasion that year. And so they actually ended up surviving, where they could easily have been destroyed in the face of that invasion. So the 6th step here is to figure out why all of this matters. For historians, this stuff automatically matters. Well, that doesn't mean it will matter for anyone else, or for high school students for that matter, right? So why does anyone care? Well, first reason is that we are trying to identify, of course, these sources of resilience in the past, partly to show that populations have followed common strategies in order to be resilient and adaptive to climate change, and that we should, maybe try and learn from their example. So for that kind of scholarship, it's important, I think. But also more specifically, if you're thinking about the military implications of climate change, often what documents like this one and many, many others that have been published recently, what they focus on is how climate change might make wars more likely. Almost never do they consider how climate change can alter the ways in which wars are fought in different environments. And so this example from the past might lead us to think more seriously about that relationship, which currently is infrequently thought about. Okay, so some conclusions here. The one I want to focus on is how it's critical that we consider very carefully consider how we link climate change to human affairs, really stressing uncertainty and complexity. Often these connections are made using assumptions, right? Whether we think about the past or we think about the present, or even when we try and anticipate the future. And it's that focus on uncertainty and complexity, in my opinion, that makes these kinds of fields so interesting. And I think that tends to resonate, at least with my students as well, right? So you're thinking about a connection that seems obvious. Well, consult the framework and see what you don't know, and what you might want to know in order to make a possible connection between climate change and social change. Now, the question that students always have is whether we can learn from the past, right? And there are limitations to that I also want to emphasize. It's not a straightforward answer here either. The Little Ice Age involved climate change of about 0.5 degree Celsius, less than 1 degree Fahrenheit, in its coldest decades. What we're heading towards is a world, according to current policies that are actually being followed right now, a world that will likely be about 3 degrees Celsius hotter than the 20th century average. So we're talking about a magnitude of change that's 6 times greater than the Little Ice Age. Even if we follow all the kind of aspirational targets that are now being set, we will limit climate change to about 2 degrees Celsius relative to that 20th century average, so 4 times greater than the Little Ice Age. So there are limits to what we can draw from the past. And of course, our societies have the ability to adapt and be resilient in ways that 17th century societies and populations did not. But we also have vulnerabilities, in part caused by the amount of pressure we're putting on the environment beyond climate change that past populations did not. So an interesting question for students to work through. I find this with undergraduate students, and I bet it would be the case as well for high school students, although you all know best, is whether climate changes in the past can actually teach us anything. And historicalclimatology.com, that site is entirely devoted to that question. So I encourage you to check it out if you haven't yet. So now I'm going to stop sharing my screen and look forward to your questions.
Thank you. I appreciate that.